Okay, so what we're going to be looking at in this section is finding inverses. And it's the same procedure every single time you find an inverse. Sometimes they're going to ask you to graph and other times they aren't. So essentially, when you find the inverse of something, you're just switching the x and y values around. Okay? So if you had a set of ordered pairs, let's start with that. If you had, let's say you had 3, -2, and 0, 5. And they asked you to find the inverse of those points. All you're going to do is switch the x's and y's around. So the inverse points would be -2, 3, and 5, 0. Okay, so knowing that, if we're looking here at these coordinates, let's do that exact same thing. So if we're looking at this coordinate right here, and this is these blue grids go out to 10 in each direction. So what is that coordinate right there? 7, 2. Okay, so instead of graphing 7, 2, what are we going to graph? 2, 7. Okay, so we'll go 2, 7. Okay, what about this next one? What's the coordinate there? 5, 5. So we graph 5, 5. That one doesn't move. Okay. This one. That's 0, 5. So we're going to graph 5, 0. And this one. -3, -1. So we'll go -1, -3. Okay, so if we connect these, it's going to look like that. Let me use a different color so that it's noticeable here. So this right here is the inverse of the black one. The green and the black are inverses of each other. Something that also happens with inverses is there's always a mirror image along the line y equals x. Okay, so if you folded it along that line, they're always going to land right on top of each other. So that's another way to double check that you did it correctly. Any questions on that? Okay, so let's try one that's a little bit more difficult. So find the inverse and graph both on one graph. So first let's find the inverse. So again I said to find the inverse of something, now we have an equation, we switch the x and the y. Now f of x is the same thing as writing what? A y, okay? So this is really y equals 1/2 x squared minus 1. That's the exact same equation. Now to find the inverse, we're going to switch x and y and then solve for y. So let's first do that. Let's switch x and y. So now x is over here and y is right here. And now we just want to get y by itself. Okay, so we're going to move the 1 first. So we have x plus 1 equals 1/2 y squared. Now what? What could we multiply both sides by to get rid of that 1/2? Yeah, let's multiply both sides by 2. So now we've got 2x plus 2 equals y squared. That's the last step. Square root it. Okay? So we've got, let's write it over here, y equals, remember whenever we square root in an equation from here, from now until forever, we put plus or minus in front of your root, 2x plus 2. So that's part of your answer, is telling me what the inverse is. Okay, and then we're going to graph it. So let's look at just this one because we know how to graph this. What kind of shape graph is this going to be? Because of this squared right here? What object are we graphing? A parabola. Okay, it looks like a U. Okay, tell me what these numbers are telling us to do to our parabola. What is the 1/2 doing? It talks about the steepness. Is it more steep or less steep? Less steep. So it would be easier to ski down if it were a hill. Okay, and what does the -1 on the end tell us?
1 to the right.
Close. We're going to move, but if it's on the end, what direction is that telling us?
Right, down.
Up or down. Okay, and it's going to go down. When is it left or right? When it's with the x in the parentheses. That's the left or right movement. Okay. All right, so this is a parabola. We moved it down 1, and it's less steep. Okay, so it's going to look like this. We don't have to plot any points. It's just a less steep parabola. Okay, now we need the mirror image over this line. So everyone draw in the y equals x. Okay, now we don't know how to graph, oh, not that, this yet. That's what we're going to learn for the second part of chapter 7. But what we're going to do with these inverses is we're just going to be looking at this visually. One thing we can do is we know how to flip these over the line because we just switch the x and the y coordinates. So right here this is 0, -1, so we'll go -1, 0. And we know this is where the vertex of our inverse parabola is going to be. And then this is just going to be you making your best sketch of a mirror image over that line. So that if you would fold that together, it would land on itself. Okay? Doesn't have to be perfect, just got to be approximately. So if you look on its side right there, it's a wide parabola going through that dot. Questions? Okay, let's try this one. So we're going to switch x and y first. So we'll say x equals y plus 5 over 3. We're trying to get y by itself, so what should we do first? I heard some people whisper it. Times by 3. So now we've got 3x equals y plus 5. 3's canceled out. And then we just subtract 5. So we've got y equals 3x minus 5. So both of these are going to be lines. We'll graph the first one in green. So another way to write this is to put the 3 underneath each one of these right here. So y equals 1/3 x plus 5/3. Okay, which is in slope-intercept form, a little bit easier to graph from. Okay, so looking at this green equation right here, where's our first dot going to go? If we're graphing a line. We want to go with the y-intercept, right? What's the y-intercept? 5/3, which is 1 2/3, right? So we're going to go to 1 2/3 right here. And where are we going to go from there? What does our slope tell us to do? Up 1 over 3. So we'll go up 1 right here and 1, 2, 3. Okay, you don't need to keep repeating that. You can just connect those two. We got a sketch of that green equation. Now let's do the red one, the inverse. Where's our first dot on that one? -5. So we've got right here. And where are we going for slope on that one? Up 3 over 1. Remember there's a 1 there, so we go 1, 2, 3 over 1. And if we would draw in this, you'll see that there's symmetry over that line as well. Questions there? So we switch x and y and solve for y to find your inverse. That's part of your answer, and then having the graph to go with it. Does anyone still need this page? Okay, let's try this one. Let's try graphing this one right away. Tell me, first of all, this is a parabola, correct? Because we have another squared right here. Okay, what is this telling us to do to the parabola? Yes, we're going right. So move right. And where are we moving here? Move up. So let's do that right now. So we're going to go right 5. And we're going to go up 3. Now, what do we know about the steepness of this parabola? It's the original size. Okay, so this is the one time where we do need to plot points when we're graphing a parabola. So let's remind everybody where they are. So we go up 1 over 1. And then we're going to go from the vertex, we're going to go out 2, and then up 4 on both sides. Okay, so we've got that parabola right there. That's the original graph. Okay, that part is review. We know how to do that part. Okay, now we need to figure out what the inverse is. So we'll switch x and y. And then we're going to get y by itself. So there's some steps here that you're going to have to follow to make sure that we're going in the right order of operations. All right, what should we move first to get y by itself? -3. So we have x minus 3 equals y minus 5 squared. Remember, we're trying to get y by itself. So what should we do now? Square root. Okay, because we have a squared right here that's kind of got it locked inside of that parenthesis. So we're going to square root both sides. So now we've got plus or minus square root of x minus 3. And now the square root and the squared canceled out, so now we just have y minus 5. And now we just add 5 to both sides. Now here's what we cannot do. We cannot take -3 plus 5, because right now -3 is underneath a root and 5 is not. So here's how you're going to write this. So we have y equals plus or minus the square root of x minus 3 plus 5. I tend to put a little line down on the end of my root just so you're telling me this is the end and it's not supposed to go over that 5 as well. Like my square root ends right there. Okay, now I'm not going to go into how to graph square root functions because we're going to get into that, but the rules are the same. So where are we moving this square root graph? 3 to the right and 5 up. So we know that that's where it's going to start. So if we go 3 to the right and 1, 2, 3, 4, 5 up, we know that's where it's going to start. That's the vertex. Now remember, this is just going to be a parabola on its side. So if we were to draw this in, and we just sketch this, your picture will look like that. Questions on that? If your parabola opens up, it's going to always open to the right when you flip it over. So if you're able to find the vertex, that'll help you kind of draw that in. Questions there? There's going to be one just like this on the test, okay, where you've got these multiple steps to get y by itself. Anyone still need this one? One more. On the test, I'm going to give you two equations and ask you, are these inverses of each other? Well, the easiest way is to just pick one of the two equations, find the inverse, and see if it matches the other equation. Okay, so if we're looking at these two, let's say we want to find the inverse to this one, and then we're going to see if it ends up being this answer. If it is, then we say yes, and if it's not, then we say no. So if we switch x and y, looks like that. And then we just get y by itself. What would we do first? Another way to write that is 1/4 x equals y squared. And then what? Heard somebody whisper it. So we've got plus or minus the square root of 1/4 x equals y. Now, let's take a look at this. We've got 1/4. This is the same thing as the square root of 1/4 times the square root of x equals y. Okay, I just separated them out, two separate roots. What's the square root of 1? What's the square root of 4? 2, right? So 1/2. So this right here, plus or minus 1/2 the square root of x equals y. What was their inverse equation? So it's really close, right? It's missing the plus or minus. I'm pretty sure I just forgot to put the plus or minus. So let's pretend it's there. I won't forget on the test. So because these are exactly the same, this one would be a yes. Questions there? Let's try this one. Okay, so let's pick this one, because it doesn't matter which one we pick, we just need to find the inverse and see if it matches the other one. All right, so remember, this is really the same thing as y, so I'm going to rearrange these and put the y on this side, and then we just have to solve for y. So we'll subtract 3, x minus 3 equals 2y, and divide by 2. So we've got 1/2 x minus 3/2 equals y. Does this one match this one? No. So that one is not an inverse of the other one. Questions there?